Hey, good morning. So today I'm going to talk about some of my history and some of my experiences in developing both Scala and languages and software in general, and try and give you a feel of some of the things that, if you're new to this or even if you're old to this, to try and avoid you making some of the mistakes that I've made along the way. So who here knows what Murphy's Law is? Now, I realise that in the UK we have a law, and it's not really a legal law. It's more of a saying, and I'm sure that every country in the world has an equivalent. And it's that if something can go wrong, it will go wrong. And when it does go wrong, it'll go wrong in the worst possible way at the worst possible moment. I believe some cultures talk about, the way buttered toast always falls butter side down, right? And when I was reading the news a couple of days ago, it reminded me because the Nordic Stock Exchange, who's heard about what's happened with the Nordic Stock Exchange on Wednesday? So when you build reliable software, you think, okay, this is not too bad. I've got my fault tolerance, I've got my failover. So they had a false fire alarm in the data center where the Nordic Stock Exchange servers are hosted. The problem is their fire suppression system went off, and it fills the room with non-flammable gas. The problem is it does it quite explosively, and it's really loud. Really, really loud. So loud, in fact, that most of the machines in the room failed permanently. So every spinning disk in that room is now trashed. And it took the entire stock exchange was actually out of hours for 6+ hours while they tried to fail over. So when you think about reliability and what's the worst that could happen to your server, there's probably a worse option. So think about your software development on a daily basis. What does it feel like? Does it feel something like this? Yeah, or like this? Or more like this? Yeah, well, I've most of my days often more like this. Software development is a real challenge, and one of my first challenges for you is the best code I've ever written is not writing any code at all. You can solve a problem without writing code, you're winning. And in fact, one of the companies I work for, my net code contribution to the company was negative 300,000 lines of code. And weirdly, the build went faster. I don't know how that works when you take away all the code. Suddenly, it runs faster, but it did. And I think Blaise Pascal sums it up really well. He says, I would have written a shorter letter, but I did not have the time. It's also attributed to Mark Twain, but I want you to think about what you do. And when you look at what you do every day, how can you do what you do better? And it's not always about throwing out the maximum number of lines of code. If it was, I have some people that I know that would be paid incredibly well based on the amount of code they generate. The problem, as many of you are aware, that means we tend to have to support it. But I'm going to have a counterpoint to that argument in a little bit. So, to give you a quick summary of the entire talk, so then you can all leave and go to the other talk if you really want to. Code's a living document. One of the weird things about code is that more than 95% of all the work I've ever done in writing software is not sitting at a blank terminal writing new software. It's looking at other people's software or other things that other people have written, or even that I've written and forgotten already, and trying to work out what the heck I was thinking when I wrote that code. Systems are living things too. Systems evolve, they change, and they have their own behaviors. So when you think about your software, you need to think about it in context. And what I mean by that is, take the Nordic Software Exchange. Take the time I had a data center underwater, and I really mean the entire UPS system was under 10 feet of water. You know, or the day that the engineer tripped over the cable and took out the production database. You know, these things happen, and when you build systems, you need to think about the worst case. But I do, and you already are, want you to expose yourself to new ideas, new concepts. Go to conferences, go to user groups, learn new things, experience new ideas. But my counterpoint is to be pragmatic about applying those ideas directly. I've spent a lot of my career getting overexcited by the new thing. Who here got really excited when Akka came out? Yeah, it was like this was the solution to all problems. Yeah, it was the answer. You know, suddenly I wanted to rewrite. Admittedly, it solves a lot of those problems with, you know, threading, and it's great in its own way. But later on, you'll find the sharp edges with whatever new technology you decide to pick up. For me, it was when you have two systems using Akka remoting talking to each other, you can no longer upgrade them independently because the protocol is a binary protocol and it's version dependent. So suddenly I had two large production systems that had to be upgraded in lockstep. And if you've ever done large production systems in banks, that's not fun. And if you take nothing else away from today, when you write code, write it for readability, testability, and debugability. Those are more important than writing the most efficient code for a computer. Most software nowadays runs so fast that you don't have to care how efficient your code is. Now, there are cases where we do. I spend a lot of time worrying about compiler performance, and for those, you often have to sacrifice readability for performance. But for the code you write every day, make it work first, make it beautiful, and if necessary, and only if necessary, make it fast. And a rule I try and live by, which is everything you touch, leave it better than you found it. So I'm not going to spend a lot of time telling you about me. I've done a lot of random things. I've worked on all sorts of systems. I'm an open source contributor. I'm a GSOC mentor, and I have a nasty habit of finding open source projects that are a bit sluggish and speeding them up. So I want to talk about your projects. So, who has written their own project from scratch at home? Yeah, everybody? Who here has contributed to an open source project? A lot of you. Who here does Scala commercially? Everybody, right, good. And who has been in a startup? Wow, okay. We've got a really, really energetic bunch. And I want to talk about Project Age. Who here has worked on a greenfield? Well, clearly anybody who's worked on a startup or who's started their own project has done a greenfield project. But who's here has worked on a project with code that's older than, let's say, 4 years? 5 years? 10 years? Yeah, it stops getting fun after a few years, doesn't it? Do you get that itchy sensation that you want to rewrite the code? What about your project sizes? Let's have a competition here. 1,000 lines of code. 10,000 lines of code. 100,000 lines of code. Oh, getting good. 1 million lines of code. Hey, there's a few, there's a couple. I'm not going to go higher than 1 million, but there are projects out there in Scala that are more than 3 million lines of code. And team size, we've all done individual stuff. Who's worked on a team of, let's say, 5 people? 10? 100? 500? It does. There are software teams out there that large. My point is, these projects are diverse. And actually, one of the things I want to come back to is that depending on what you're writing, the diversity matters. If I'm writing commercial software for a large organization with 500 developers, it is much, much more important to communicate with other developers than it is to be clever. So I said at the start, I'm about making code beautiful. And what makes code beautiful? And it's not actually about having pretty code for slides. Now, if you give talks, you often want little nice little code snippets that look really beautiful. But I'm going to put it a different way. Firstly, I want the code that's fit for purpose. It does the job it's designed to do. That means not only is it well written, it's well tested, and it's well understood. And comprehensible. I know I keep saying it, but more importantly than any performance aspect, your code, you might have just discovered monads. You might have just discovered applicatives. You might have a new technology that you believe is a solution to all software problems. But you're working in a team. And that means that you need the rest of your team to understand it too. Now, a friend of mine has a solution to this. She's amazingly clever, amazingly open to new ideas, but if she adds a new functional feature to her software, so if she suddenly decided they're using applicatives, she will write the initial version of the code. But it will be code reviewed by somebody else on her team. And once she's written it, all the updates will be done by somebody else. And she will pair with people, and she will educate, and she will teach. But her whole goal is not just to look like she's the smartest person in the room, regardless of whether she is or not, but to uplift her entire team. Otherwise, you're in that horrible point where you are the only person in the room that can support the software, which means you get all those nasty calls at 3 a.m. And for me, I found that often, if I'm too clever with my code, I'll come back in 6 months when I have to fix a bug in it, and I don't understand what the hell's going on either. But don't get carried away. So, here's a bit of code. I'm sorry to say it's a tiny bit small, probably for the back of the room, but I think that's quite reasonable code. Yeah? Would you agree? It's nicely functional. It's fairly easy to read. My problem was, I had a problem with this code. And the problem was, the exception I got was null pointer on line 4. Which, the JVM doesn't have a concept of position within the file. It has lines, and it says line 4 has a null pointer. And this was a production system. Could I replicate the bug locally? Of course not. Don't be silly. That would be too much fun. So when you think about writing really tiny code, and we always think, you know, shorter is better and functional is better. And I don't disagree on that count. I want you to think about writing this instead. And we may have debates, and I'm more than happy to stand outside over coffee and debate the clearest way to write the code. But if you wrote the same code, and this is exactly the same code, written further out, it means when I now get a null pointer on line 7 instead of line 4, I at least have some clue of what's going on. We all use libraries. especially nowadays, most of my code really is someone else's code, right? You know, if you look at my project dependencies now, the number of lines of code in my project dependencies is orders of magnitude bigger than the code I'm writing. And that's a good thing. Because we as software developers have a problem with the not invented here syndrome. Right? We've all done it. We've all gone, oh, just put some print lines in my code. Who needs a logging framework? Right? Or, you know, Akka, it's okay, but it's got some weirdy bits in it. I don't want to deal with those. I'm just going to write my own little thread executor. It'll be fine. What's the worst that can happen? And what happens is you spend a couple of weeks having a really fun time, right? Writing new code to solve your problems is really fun, right? It's awesome, you know, hacking away. Great. Feeling really productive because I've written thousands of lines of code. It's an awesome day. But then, possibly sometime later after you've released it to production, you find those weird corner cases about thread starvation or, you know, proper mutability or the fact that it doesn't perform as well as you thought it did. And then you go back and you look at the Akka documentation and suddenly that paragraph in the middle about why they do initialization the way they do, why you never let anybody see the object other than via an actor ref. Suddenly that makes sense. But normally only after you've been burnt by doing it the wrong way. Especially logging. I don't know what it is about logging, but logging is one of those ones where everybody starts thinking, I don't need a logging framework. And then at some point has to go through and replace all the printlins with actual real log statements. My first job ever, after I'd left university, the production system, it was quite good. It was written in Java. It was awesome. It supported the trading desk. It did everything trades wanted, but it was a bit sluggish. I spent a little while. I'd just written a compiler. That was one of the things. I'd written a Java compiler in Java, or a JVM in Java. That was the first. That's part of my research. So I knew quite a lot about the internals. So I profiled it. And does anybody guess what it spent 30% of its time doing? So 30% of the entire application time. Any guesses? Logging? It wasn't even logging. It hadn't got as far as logging. It spent over 30% of the application time adding strings together. Right? The JVM was spending all of its time and all of its processing power concatenating strings. So it would do, you know, if hour is greater than 10, hour, otherwise 0, in quotes, plus hour, plus colon, plus minute. And this is in the old days of the JVM where that wasn't optimized by the jitter. So for every string it built 30 intermediate strings. Right? The weird part was just putting in a string builder at the time made the application literally 30% faster. And you wouldn't believe how happy that made my customers. But when you do take libraries, you do have to review them critically. So it's very easy to pull in, you know, Bob's jar because it's just there and it does something useful. But when you look, especially at open source software, you should be critically analysing the software the same way you do a code review on your colleague's code. So you should be, you know, looking at the thing, looking at its history, looking at its code quality, and then making a decision whether to use it or not. But I came across a really interesting article recently by a guy called Doug Tangram, and he's part of the Rust community. He's not a Scala developer at all. But one of the things he said is, you're going to come up with a new idea. for a new library. He said, the first thing you should do is stop. Right? Don't write any code. He said, go and look if somebody's already written a library. So you go and you search GitHub and you find a project and you find it's got no documentation, you don't know how to build it. So if that's the case, why not start there rather than starting from scratch? If there's no contributing file, add a contributing file. So the next person that comes across can see and evaluate it quicker. And if you find there's some difficulty or some build hint that you needed, add that. But you should be very reticent about starting yet another JSON library. And I said this to somebody a few days ago, and they said, oh, that's a coincidence. Because he had literally just started writing a JSON library. But my point is, if you do, it is better to start and work together and contribute back than it is to just build another project. So instead of having 7 projects which are all mostly dead, we now have 8 projects that are all mostly dead because you started it, you hacked some code, you got it working okay for you, and then you abandoned it. So just think about, adding the greatest value. One of the things I learned the hard way is when I did a startup, I had come from a commercial organization. So my experience up to that point had all been about building big software. So having tests, having code reviews, building it just right, building it performant, doing all your due diligence as you should do in a large company. And I wish I'd learnt this earlier. But it's not about the code. In a startup, your job is not about writing perfect code. In fact, some of the biggest startups in the world started in Perl. Why? Because they could quickly hack something together. And as a startup, your job is not to prove you're a really clever software developer. It's to prove or disprove whether you are right about the fact there's a market there. It doesn't matter how beautiful your code is and how fast it is, how scalable it is, if nobody cares. If there's no customers. And it took me, for me personally, I learnt this far too late, and it cost me a year of my career and quite a lot of my finances to realize the fact that I was building something that no one cared about. So your goal instead, and this is, it took me, I suddenly realized it's the drivers behind what you're building are different. Right? If I prove there's a business, if I prove there's a market, if I prove there's people out there that want it, then you carry on going and you build it. And then hopefully you've got time and potentially money to build it again and build it right. So you end up wanting to minimize delivery time. And in fact, one recommendation for starters is often to throw up a web page and see if anybody cares, rather than actually building any software at all. Or when you build the software, what's the minimum thing you can do to prove or disprove whether or not there's value there? It doesn't matter that it's unstable. It doesn't matter that it's hacked. If I can crunch the data set and show there's data there that's worth extracting, that's far more important than building it right. And the last point on this is scalability. Right? You can spend months and months building scalable systems, but the answer is it doesn't really need to be scalable when there's 4 users. Yeah, my phone can support 4 users, probably 400 or even 4,000. if you reach scalability problems, hopefully then you've got finance, right? You've got paying customers, and at that point you can scale, right? You can buy hardware, you can throw hardware at the problem. You know, AWS is wonderful, right? I can literally throw hardware at problems. Scalability is the last thing at the start of a startup that you should be worrying about, and you worry about it when it actually happens, if it actually happens. One of my other favorite fights is, who here thinks you should ban all vars in software? Oh, we've got one at the back. That's surprising. I thought we'd get a better response to that than that. There's one brave man at the back saying vars should be dead. Well, this is going to be an easier fight then. So I think mutability is okay. And in fact, one of Martin Odersky's keynotes actually said he uses mutable vars. Right? I can't, that if that's not, validation, I don't know what is. Mutability is okay in context. Right? I totally agree that there's a whole bunch of the world where mutability should be completely banned. Right? But inside a method, inside an actor, those places are fine. The reason is you've protected yourself already. Inside an actor, you are in a singly threaded context. Nobody else is going to try and mess with your code. If adding a val, if using mutable state makes your code easier to read, easier to write, and easier to reason about, then why not? And one of the things, if you look at a lot of the pull requests on Scala C that I've been doing recently, I'm quite happy to use a var inside a method as long as it's externally immutable. So I am absolutely, utterly sold on immutable data structures. When I hand you something, no mutation. But when I'm building that structure, that's fine. I can do what I like behind the scenes. And in fact, Scala.immutable.list is, in fact, mutable. If you go and look at the source code, the tail is mutable. And the reason for that is the performance reasons we've just talked about. Now, you can't change it as a user, but within the Scala core libraries, the list can be built from the front. And if you think about building a list, they're really easy. If you want to map over a list and create a new list, how do you do that efficiently without pushing the things into a stack and then building it in reverse? How do I do it functionally, immutably, and efficiently? And the answer is you can't. But what you do is the map method on list builds from the front. The list builder appends to the tail. But once that list has escaped the map method or the list builder, it is effectively immutable. You can't go and change it. So there's a way to think about this stuff. Yes, immutable data structures. But don't be afraid to use a var or mutability when it's necessary, but be careful with it. Let's talk about macros. Who here has written a macro? Yeah. Who here has suffered a lot of pain writing macros? Right. Macros are incredibly powerful. They are the escape hatch of the Scala compiler. Right? They allow you to dig underneath and do some stuff you couldn't do otherwise. But my advice is simple. They should be a last resort. If you can write it in sensible Scala code, do it. Debugging macros is painful. It's so painful. And it's also really hard to get them right. I found a really interesting fact recently, which is a friend of mine discovered 3 bugs inside the shapeless macros. Now, if there's anybody who's going to write a macro right, Miles is one of those people. But actually, he found that there were certain cases where it didn't update its position properly. And that can cause all sorts of weird and wonderful problems. So, writing macros is hard. Writing macros that are right is really hard. And in fact, one of the things that Miles has been doing in the past year or so is actually trying to reduce further and further the number of macros that he needs. So I think at one point he had, I think it was 11, and he's now down to, I think it's 3 or 4, and he thinks he can get it right down to 1. And a change in the Scala compiler to enable one of the features. But by doing so, that surface, that opportunity to introduce bugs has gone right down. And just use them with care. So again, macros should be your last resort. It's an escape hatch if you need to do something that you can't express in code. Everything fails. I know I started with this talk talking about the Nordic Stock Exchange, but who here thinks that AWS is going to fail? What, a 2 or 2? Right. So last year, AWS US East 1, which is where a lot of the websites you all know and love are hosted, had a 5-hour outage. So you've put your stuff onto a distributed platform where everybody takes care of everything, and it was down. It was dead. There were whole chunks of the internet which simply didn't work that day. So even when you scale, even when you have distribution, even when you have failover, stuff will fail. That's software, right? We write code with bugs in, right? I think, they always say that software, coders are people converting coffee into software bugs, I think. Hardware fails. So I know some of the people that use hard disk to capture video for one of the big international airports. And they have over 10,000 hard disks. Now, if your mean time between failure is 10,000 hours, how many hard disk failures do you get a day? With 10,000 drives? 24? So, they have a room of spares. They literally have a room full of hard drives, ready to go. So they drop one out, drop the new one in. But no system, no machine will last forever. Even if you run a machine hard enough, the CPU will eventually fail for long enough. So you've got to build for failures. Operating systems fail. And as I said, even data centers fail. I know the Nordics systems failed recently. My personal favourite for me was I worked for a company who had a data center in upstate New York, and all their servers were on the 2nd floor. The nearby river burst its banks and flooded the basement. And the basement was, the 1st floor was basically up to waist level. The problem was all the servers were fine. All the batteries, on the other hand, because those are heavy, so they put them in the basement, were under several feet of water. Stuff will fail, and you've got to build that into your process. Maybe, for what you're building, it doesn't matter. Right, your cat's website, with nice pictures of cats and likes and dislikes of cats, if it's down for a few hours, it doesn't matter. But if you're building a healthcare system where reliability is key, you need to pay attention to it. But when you think about reliability, you've got to think about what you're going to do and what you actually need. As I say, for healthcare systems, you might care about it being up 24/7, 365, and failing in an incremental way. So even if one of my core data centers goes down, the systems are still usable. Whereas for certain systems, you might care more about stability, as in correctness. So you might have a single point of failure. But the point is, whilst that single point of failure is up, your system will be in a consistent state. So do you care about consistency or uptime? And you play these trade-offs. And each of these has an effect on cost and time and effort and testability. And if you do have a failover system, if your system is hot, I challenge you to go and switch off your primary server in the middle of the day. Because you'll be surprised how often the hot backup doesn't come up. Release processes. Please automate your release process. Do not have a spreadsheet with 50 steps in. And the laugh in the room tells that somebody's had that, and I've had that. Yeah. If you have a release process where somebody who's not the software developer, or even someone that is the software developer, is following a manual process where they type in the line of text that they type in the console from the spreadsheet, and they check the output matches the second column, I will guarantee 1 time in 2, they will forget row 7. And then look at you really confused when the system doesn't work because they forgot to actually deploy it. And of course, today it's row 7, tomorrow it's, steps 14 to 19. And literally I've worked with a software process where you had to sit with someone to verify they were actually doing the steps that they were told to do. Just do it. Your release process should be a turnkey solution. As in, when you decide, and maybe you need to sign off, maybe you've got to be careful about when you can release and who's happy, that's fine. But when you decide to release the software, it should be an automated process. Maybe flipping a link, maybe something simple. But on that note, never, ever, ever patch jars directly in production. We had a production system where the release process was so painful, the manager, in his wisdom, decided that the correct way of releasing software for patches was to stick a jar on the front of the class path, because one of the writable areas we could actually point the class path at. So people were FTPing files onto the production server and sticking them on the front of the class path. Just please don't. If you know anything about binary compatibility, this is the best way to make your production system completely unusable. And also, talking about failover, when you fail over to your backup system, you'll find that you don't have any of the production fixes you've put in for the past month. Just fix your release process. And anybody who wants to hear all the war stories, we can sit in the bar afterwards. There are so many. And I'm sure there's many, many painful memories in the room as well. As I say, software isn't built in isolation anymore. It's not a one-man group. I've worked in software groups from 10 people up to supporting 500 software developers. And as I said, I know I mentioned this earlier, but I just want to reiterate it. Keep it simple. Keep it simple, or be prepared, willing, and do it. Don't even just be willing. Find a way to educate your colleagues. If you think you've got a new software technique, if you think actors are the right answer in this case, or monads or applicatives, or tasks, maybe cats is the answer to make your program much easier to understand. You need to educate the rest of your colleagues so they all understand it as well. And don't lie to yourself. Every time I've written a perfect bit of code and I've declared I don't need tests, and my manager's gone, write some tests, I guarantee you'll find a bug. It just happens. Use the tools. We have a lot of tools available in the community. You should be writing unit tests. You should be writing integration tests. You should be mocking the bits you can't easily test. Write your tests in a way that works. Use coverage tools. Use code analysis. And my best piece of advice is turn on every single warning your compiler or your tools can generate. Now in C, you used to have miner's wall, and it used to be fairly abusive about, you know, failing and giving you lots of errors about your code. Every software project I work on now, I turn on fatal warnings, and I turn on all the warnings I can, because the fact that these two things are not comparable tends to point out the fact it's a software bug long before it fails. Quick word and optimization, make it work, make it readable, and only then make it fast. Questions? Deathly silence. It's rather one. For which particular applications have I used macros? So one of the few things I've used macros for, or written my own macros for, was debug logging. So if you call a method, I gave a talk at Scala Exchange a couple of years back about the cost of actually putting logging statements in, even logging statements that don't log anything to the console. So I wrote a macro that basically said, if debug is enabled, then execute the actual log line. And that made it, when you turn debug off, made it made the code run a lot faster, because it didn't generate either a closure for the message or generate any strings. You will all use macros because a lot of you use shapeless or depend on a project that uses shapeless, but generally I avoid like the plague writing macros. Yeah. You're welcome. Any more? Oh.
Concerning this list for how to build a release, maybe if we can say it's like an intermediate step. So the one kind of project, you have a chaotic situation that there's one guy who kind of knows how to do the release, and sometimes it works, and then you advance to this list, but you should see it as a step, and you should advance to automate the steps in the list, or the whole thing, at least to a few scripts or whatever.
Yeah, I thoroughly agree with that point. So if at the moment your release process is one guy manually SCPing files and you hope that he remembers to do it right, having a list at least documenting your process is a first good step to making a reliable software process. I completely agree. Any more? Yes.
Yeah, first of all, thank you on the great talk. I couldn't agree more. This is like a constant struggle for me as well. Especially thank you for like the make it work, make it beautiful, make it fast part. Rinse and repeat, of course. Like that's what you should have like in every project. My question would be, like my everyday struggle is to constantly repeating the keys principle to people when you're working in Scala community is like really hard. And I've like worked with people who tends to create additional DSL for any additional purpose. And the problem with Scala that you actually have everything to do this.
Yeah.
And when you like see such code, your previous Scala experience, your library experience in Scala doesn't matter anymore. You should learn DSL from the scratch from this person. So when we thinking about the kicking off of the project, we need to understand that every project means to be scaled, like in terms of like source code, team, and so forth.
Mm-hmm.
And with Scala and the level of abstraction that it provides, it's difficult to be sure that your team will scale properly because you need to have all this education stuff. How do you sell, like, if a person comes to you and asks, should I choose Scala for my startup, how do you sell it?
How do I sell Scala? That's an interesting question.
I'm so sorry, but we are
But we're also out of time. How about we discuss that at the coffee break?
Yeah.
But yeah, thank you all very much.